Hi everybody, in this video, let's look at the effect of changes in the set of data to the value of mode, mean, and median. If each value of the set of data is changed uniformly, you can apply this concept that I'm going to share with you to help us to get the new mean, new mode, and new median easily. Okay, what does this change uniformly mean? Let's say I have a set of data 4, 3, 4, 6, 10, 9. Okay, so if this data plus 1, let's say if this data plus 1, the rest of the data will plus 1 as well. So it becomes 5, 4, 5, 7, 11, 10. All the data here plus 1. They change in the same manner. So in this case, this called change uniformly. If this one times 2 become 8, let's say, okay, let me erase this one. If this times 2 become 8, the rest will times 2 as well. 3 times 2, you get 6, 4 times 2, 8, 6 times 2, 12, 10 times 2, 20, and 9 times 2, 18. So this called change uniformly. So if this is the case, they change uniformly, you can apply the concept that I'm going to share with you here. Now, we just let the original value of mean, mode, median be x, y, and z. So if let's say they change uniformly, they add or subtract a constant value of k. Every single data add k or minus k. So the new mean will change in the same manner. They will plus k or minus k. Mode also the same thing. You take the original value of mode plus or minus k. If every single data here plus k, the new mode will plus k as well. If every single data here minus k, the new mode will minus k as well. So same thing happened to median, plus or minus k. So this concept not only can be applied for adding or subtracting, it can be applied for multiplying or dividing as well. You will notice that here I only write multiplying, but it can be also used for dividing, because divided by k is actually the same thing as time 1 over k, right? So you can still use this concept to help you to get the new mean, new mode, and new median if every single data here divided by a constant value. Okay, so same thing, we just let the original value of mean, mode, median be x, y, and z. So if every single data here times k, the new mean will times k as well. The new mode will times k as well. The new median will times k as well. So you take the original value of mean, mode, median, you times k. Okay, let me show you an example over here. So always remember, when you are asked to determine the median, always need to make sure that you arrange all the data nicely. Okay, so now you will notice that this data haven't arranged nicely in an ascending order or in an ascending order or descending order. So first thing I need to do is I have to rearrange all this data. Okay, personally I normally will arrange them in an ascending order. So I will start from the smallest and to the largest. So it becomes 3, 4, 4, 6, 9, 10. Okay, so now I can start to determine the median, mean, and mode. Okay, let me determine the mean first. Mean, I think it should be no problem. You take all this data, you plus together, and then divided by the number of data. 1, 2, 3, 4, 5, 6 divided by 6. Okay, just use your calculator to help you to get the answer. Okay, this one should be 36 divided by 6. So which is equal to 6. Okay, how about mode? Mode, look at the data which has the highest frequency, which is 4. Okay, last one, we go to median. Okay, so how to get the median easily? If this is not a, if this is just a field of data, we can use this method, right? You just cut here and cut one from left and right, do the same thing until you get the middle value. So you will see here we have two middle value, right? So you take 4 plus 6 divided by 2, which is equal to 5. So this is median. So if you don't want to use this method, you want to use a formula to help you to get the positions of the median, also can. You can do this way as well. 1, 2, 3, 4, 5, 6. We have 6 data, right? We take 6 plus 1 divided by 2. 6 plus 1 is 7. 7 divided by 2 is 3.5. Okay, but be careful. This is not the median. This will just tell you the position of the median. So first, second, third, 3.5 is over here. So it means that we have to take the third value, which is 4, plus the fourth value, which is 6, and then divided by 2. So we will get exactly the same thing. Now, let's try if every single data here plus 2. What is the new mean, new mode, and new median? Now, every single data here plus 2, they change uniformly. The 3 will become 5 plus 2, right? 4 will become 6. The 4 here will become 6 because plus 2. This will become 8. This will become 11. And this will become 12. So let's get the new mean, new mode, and new median. If you understand this concept, you don't need to calculate. You know the new mean is 6 plus 2, which is equal to 8. New mode is 4 plus 2, which is equal to 6. And the new median is 5 plus 2, which is equal to 7, right? So let's say we don't understand this and we forget about this one. So we want to calculate mean. So this is a new mean. 5 plus 6 plus 6 plus 8 plus 11 plus 12, and then divided by total number of data 1, 2, 3, 4, 5, 6. Okay, so this should be 48 and this is 6. So the answer is 8, right? 6 plus 2. Okay, so let's try mode. Okay, mode from here, you know this is 6, right? Okay, then let's go to median. So median, look from here, look at this data. Cut here 1 and cut the left hand side 1, cut the right hand side 1. Do the same thing until you get the middle value. Now I have 6 and 8. So what I need to do is I take the 6 plus 8 divided by 2. This is 14. 14 divided by 2, which is 7. Okay, let's check. So this 8 is actually 6 plus 2, right? Original value plus 2. And this mode is 4 plus 2. Original mode plus 2. And the median is actually 5 plus 2. Original median plus 2, right? So it's the same thing if you minus 1. I ask you, what's the new mean, new mode, new median? You just take all this original value minus 1. Okay, how about multiply? Okay, now let's try multiply. Okay, if every single data here times 3, so this will become 9, 3 times 3, 4 times 3, become 12, 12, 6 times 3, 18, 9 times 3, 27, 10 times 3, 30. Okay, so let's calculate the new mean, new mode, and new median. If you understand this concept, you know the new mean is actually 6 times 3, which is equal to 18. New mode is 4 times 3, 12. And new median is 5 times 3, which is equal to 15. Okay, let's check correct or not. This is new mean. 9 plus 12 plus 12. 9, 12, 12 plus 18 plus 27 plus 30. And then divided by the number of data 1, 2, 3, 4, 5, 6. Okay, this one you should be able to get 108 divided by 6. Okay, the answer is equal to 18, right? So 18 is actually equal to 6 times 3. Okay, now let's try mode. So this is new mode. From here, we know it's 12. 12 is actually equal to 4 times 3. Okay, let's try the last one, which is equal to median. Which is median. Let's see. So the median is 12 plus 18. 12 plus 18 divided by 2. So this is 30 divided by 2, you will get 15. The 15 is actually equal to 5 times 3, right? Okay, so now you understand how to get the new mean, new mode, and new median. If every single data in the set of a data change uniformly. How about we have plus and plus, minus, or multiplying and dividing combined together? Okay, let's try one more. Okay, now let's try take every single data here minus 1, then divided by 2. So minus 1 first, minus 1, then divided by 2. Okay, so 3 minus 1 is equal to 2. 2 divided by 2 is equal to 1. So 4 minus 1 is equal to 3. 3 divided by 2 is equal to 1.5. This one the same thing, 1.5. So 6 minus 1, 7. 7 divided by 2, 3.5. 9 minus 1 is equal to 8. Divided by 2 equal to 4. And the last one, 10 minus 1 is equal to 9. Divided by 2, 4.5. Okay, let me double check again. Oh, I think here... Oh, sorry, I made a mistake here. 6 minus 1 is equal to 5. 5 divided by 2 should be 2.5. This is 2.5. Okay, so the rest should be correct. 9 minus 1, 8. Okay. Okay, now we can start to calculate the new mean, new mode, and new median. So if you understand the concept that I told you here, you can get the new mean, new mode, new median easily. What do you need to do is you take the original value minus 1 and then divided by 2. Okay, let's see correct or not. Let's find the median, mean first. This is new mean. So 1 plus 1.5 plus 1.5 plus 2.5 plus 4 plus 4.5 divided by the number of data over here, 1, 2, 3, 4, 5, 6. Okay, so let me check. 1 plus 1.5 plus 1.5 plus 2.5 plus 4 plus 4.5. Okay, this is equal to 15 divided by 6, which is equal to 2.5. Okay, so if you take this value, 6 minus 1, you will get 5, right? 6 minus 1, you get 5. 6 minus 1, and then divided by 2, you will get 2.5 as well. Okay, how about mode and median? mode. So mode, we know which is the data which has the highest frequency, which is 1.5. So the 1.5 here, you take the original mode minus 1 divided by 2. So 4 minus 1 is 3, 3 divided by 2 is 1.5. Correct, right? So how about the last one, median? Okay. The median is 1.5 plus 2.5 divided by 2. So this is 4 divided by 2, which is equal to 2. So the 2 here is actually equal to 5 original median, 5 minus 1, and then divided by 2, right? 5 minus 1 is equal to 4, divided by 2 you get 2. Okay, so now you know how to get the new mean, new mode, and new median easily when the set of data change uniformly. Okay, how about let's try one more example. Okay, so mode, mean, and median. So I would suggest you to write down first mode, mean, so that we won't mess up something. Sometime we might see wrongly, so it's better we write down all the important information first. Mode is equal to 10, the mean is equal to 9.5, and the median is equal to 8. Okay, now easier for us to see the value of mode, mean, and median. Now find the new mode, mean, and median if the every value in the data is divided by 2, subtracted by 3, added 2, then divided by 4. So it means that they change uniformly. Okay, let's try A. The new mode will be equal to 10 divided, right? So you have to divide 10 divided by 2, which is equal to 5, right? You see, so you understand this concept, very easy to get the new mode, new median, and new mean. So how about new mean? Take the original mean divided by 2, you will get 4.75. Okay, how about the new median? Take the original median divided by 2, which is equal to 4. Okay, now let's try part B. New mode. This is subtracted by 3. Every value in the data is subtracted by 3. So the new mode will subtracted by 3 as well, which is equal to 7. Okay, so how about new mean? Okay, we look at the original mean, 9.5. Then we take it subtracted, take this value minus 3. So you will get 6.5. So this is the new mean, and last one is a new median. Take 8 minus 3, and you will get 5. Okay, the last one is combinations of plus and divide, but the concept still can be applied over here. So we still can get the new mode, new mean, and new median using the concept that I told you just now. Okay, so every value in the data is added to, then divided by 4. So the new mode will be You take 10 original mode, add 2, divided by 4. So you get 12 divided by 4 is equal to 3. Okay, so how about new mean? Same thing, take the original value plus 2 divided by 4. Okay, let me press the calculator. $2.875. Okay, the last one, median. New median. Take the original median plus 2 divided by 4. 8 plus 2, 10, 10 divided by 4, 2.5. Okay, so this is the way how we solve these type of questions. Okay, so let's try one more example. Example 2, given that the mean for the set of data k is equal to 9. So this is the mean given here. So this is the original mean, which is equal to 9. So we need to find, okay, I forgot to type this one. Okay, I need to add in this sentence here. Describe how the mean of k would change if a number 10 is added to the set of data k, a number 18 is removed from the set of data k, and a number 9 is added to k. Okay, so the original mean is equal to 9, right? But in this case, we cannot apply the concept that I told just now because this is not changed uniformly. The set of data just add in one number, not different from just now. Just now, every data, they change in the same manner, right? So this one difference. You just add one more data inside, which is equal to 10, and then 18 is removed, and then added 9. Okay, so we want to describe how the mean of k will change. So the mean will become, the new mean will become larger, smaller, or remain unchanged. So before I show you how to solve this one, how to describe the changes, let me give you an example over here. Let's say you have a data 10, 10, 10, 10. So the original mean will be equal to 10, right? So since you take all this plus together, you divide it by 4, you get 10, right? So how about if I add in one number which is greater than this mean, 20, for example. So what is the new mean? The new mean will be greater than 10, right? It will become larger. If you calculate, the new mean should be equal to, you take 20, so divided by, so this is 20 plus 40, 60 divided by 1, 2, 3, 4, 5 should be equal to 12. So you notice that increase. The new mean increase. So same thing, if you remove the data which is greater than mean, it will decrease back. Okay, so how about if I add in a data which is smaller than the mean? Let's say I add 5, go in. The original mean is equal to 10. So what is the new mean? You take 10 plus 10 plus 10 plus 10 plus 5, then divided by 1, 2, 3, 4, 5. So you should be able to get 9. Okay, let me check around that. 45除以5. Okay, correct. 95. So it will become decrease, become smaller. REASE. So if you remove this value, which is smaller than the mean, if you increase back. So if you add, okay, last situation, Let's say 10, 10, 10, 10. So the mean is equal to 10, right? So you add one more value inside, which is equal to the mean, which is 10. So how about the new mean? The new mean will remain unchanged, which is equal to 10. So same thing happened here. If you remove a number, a data which is equal to mean, the new mean will remain unchanged. So if you understand this concept, then you will be able to describe the changes of the given situation here, the changes of the mean of the given situation here. Okay, let's look at the first situation. A number 10 is added to k. So before we describe it, we have to look at this added number. This number is greater than the mean or smaller than the mean. If this number is greater than the mean, when you add this number inside, the new mean will actually become bigger. The mean is shifted to a value which is larger than 9. So as I showed you just now, right? So when you add in this value is more than 9. So it will actually make the new mean become bigger. Okay, let's look at B. Remove this value. Remove 18 from K. So we try to think this way first. Maybe now you see remove, you start to get confused, right? So you try to think, if you add this 18 go in, this 18 is actually more than the mean more than the original mean. So the new mean will become larger. Now you remove it, it becomes smaller, right? So the mean is shifted to a value which is smaller than 9. So this value is inside this data. Now you remove it, and this value is actually more than the mean. When you remove it, the mean will become smaller. So how about I give you an example? Maybe it's a little bit hard for you to understand this one, right? Okay, let me think an example for you. Okay, now let's look at this example. I have a set of data 2, 5, 6, 8. Okay, so I calculate the mean. The mean is actually equal to 5.25. Now I remove a data which is bigger than this mean. So since I want to remove a data which is bigger than this mean, 5.25, I remove 6, let's say. Now it becomes 2, 5, and 8. Now let me calculate the new mean. You take 2 plus 5 plus 8, then divided by 3. You get 5, right? 7加8 15 15除以3 5. So you notice that the new mean becomes smaller, decrease, right? So this is what I told just now. The new mean will be shifted to a value which is smaller than 9. Okay, so now you should be able to understand, right? Now let's try the last one. A number 9 is added to k. You will notice that the 9 is actually equal to the mean. If a number is equal to the mean, you add it to the set of data. Let's say the original. Now let's say you add in one more data. You can try add in 5.25. Now you take 2 plus 5 plus 6 plus 8 plus 5.25, and then you divide it by 1, 2, 3, 4, 5 divided by 5. You get back exactly the same mean, which is 5.25. So the new mean will remain unchanged. So the mean remain as 9. Okay, so for this video I stop here first. Hope that you understand better after watching this video, and thanks a lot for watching. See you next time. Bye bye.